Yeah, it is a little weird. So can I unpack anything for you guys when it comes to the exam or going over classes or I know that for my 1400 class, I got a bunch of students are like, oh my God, I don't understand functions. It's been like 3 or 4 weeks and people don't want to speak up. And like, I'd rather you guys speak up now if there's something that's confusing you, if it's way earlier in the term, than not speaking up. So for example, C strings, although we technically covered them 1400, there doesn't hurt to go over it again, right? There's a lot of stuff being thrown your way. So I forget half the stuff I see, right? So it's fine. Just well, we can just go over it again if you want. Would you want me to go over C strings? But although strings themselves are more more likely to show up on the exam, and strings are objects in particular. Nothing. Oh, that crap. Oh, MFC version of crap. Oh Lord. This is one of those things I have to figure it out each and every time. That might be a different type of string. Okay. Yeah. MFC C string. Yeah, MFC, it's Microsoft. They did their own everything. They made their own JavaScript standard that no one else follows either, right? It's just yay. So C strings in C string, I think, is a class in MFC that happens to be Unicode, so not ASCII, meaning it's internationalized, as in you can make it into Mandarin if you wanted to. You can make Japanese, you can make it, put Arabic in there. You can do all sorts of different languages, unlike ASCII, which is only for essentially for the English language and a little bit, I think you could do French and a couple of other European languages, but not much. It's not designed for anything other than English, essentially. Um, and maybe Russian, I'm not sure. I have to look into that. But the fact of the matter is, it's designed for ASCII was designed for the English language, and it's not really designed for the world and actual text. So Unicode's a great thing to deal with, but that just means there was a whole lot of fragmented standards everywhere. If you look at my sample code, I hope I hit a C string in there somewhere. I think, as far as I remember, it's a class. I could be wrong. Yeah, I'm going off of really faulty memory here. I could try and pull it up, but if you want MFC, we can do that. I just wasn't expecting to teach about MFC at all because it's not on the exam, which is next Wednesday at this time. I really hope more than two people show up for that. Oh, five. Nice. Okay. So again, anyone that just joined later, what do you want me to cover? I can cover whatever you want. Turns out MFC is something that Ethan wanted to cover, but I wasn't quite as prepared for that one. MFC is one of those things I purge from my head every time I learn it. I relearn it every single term, and I purge it from my head every single term. Um, but I'm more than happy to try and pull that up again and relearn it again. Uh, but if you want to go over anything that's going to be on potential on the exam, I'm more than happy to do that as well. Oh, for your project. Okay. So if it's just a character array, it's just an array of characters and there's a zero at the end. That's all it is. Other questions? I have nothing I really wanted to go over, guys. So if it's this is meant for you guys to pay, to fire questions my way, even questions you think are, I have a friend that doesn't understand what an object is. Can you explain it? That's fine. You know, I have a girlfriend in Canada, kind of thing. It's you can. It's not. I'd rather go over stuff that if you're having any discomfort with anything earlier in the term, I'd rather go over it than everyone staying quiet. This is going to be a fun video to watch for anyone else watching it after the fact. Just in time. There we go. Now I'll get it one space. Absolutely, not dumb at all. All right. What do we want to do with pointers? Let's see what we can do with pointers. Well, pointers are one of those, how do you want pointers in objects or do you just want pointers in general? More than happy to do either. Okay. Pointers are the thing in C that throws everybody off. It's all these other languages have them, they just hide them. A pointer is just the location in memory that I have, which most of the time, if I have a variable, I want, I have this little fake project here from earlier, is this new point3D. I was working through some examples with a student yesterday. But why don't we just add some more stuff, code to it? Okay, so, all right, and let's do int x test. And that's all p-test. Although that sounds like you're doing a drug test of some form. Okay, and then let's do a couple of things here. Okay, I'm going to change test. All right, I'm going to change test very indirectly. So I'm going to do my test num. I should have a CFCM, shouldn't I? CF. Okay, and let's do dereference, dereference. All right, and I think I may need to do the standard thing here. I should have just used standard namespace, but okay. Here's what we're going to do. I have something very, very simple here. I just have the number 4. The variable. It has to be stored somewhere. And let's also do an array as well. So int okay, and yeah, we'll just deal with that from there. And it'll all hopefully make sense in a second. I actually have to just write some code out here. The important part of this whole thing is I want to see where all these things are and where they're pointing and what they're pointing to. Let's also and it will hopefully all make sense in a second. Okay, and okay, great. For some reason I got this thing. Okay. And center. All right. All right, let's walk through this. I have a variable, simple variable. It's an integer. It's the number 4. Okay, it got to be stored somewhere. It has an address in memory. Somewhere in my RAM or wherever I'm storing these variables, it has a location. I can get that location. If I put an ampersand in front of it, it says, no, no, don't give me what's in the box. Tell me where the box is located. It's the equivalent of me saying, uh, where is this, you know, where is this particular plug? Like every time something runs out of power, we need to plug something in. My wife says, where is it? Do we have a USB-C to USB-A connector or something like that? I say, so either I go and grab the cable itself and give it to my wife, the direct thing. That is what this thing does. Give me the USB-C to USB-A cable, but here you go. Or I could say, no, go downstairs. It's in this box over there. Go to this location and go get it yourself. You can find there's other things you want. That's the location, not the actual item, the location. So the way to get the location is I put an ampersand. I hate the syntax, by the way. It still throws me off after all these years. 20 years later, I still get thrown off by the syntax on this thing. Give me the location of this thing. When I get the location of it, I'm going to use this syntax to say, no, I'm pointing. This is the address of this. But I can do what? That's still a number. It's a location in space, but it's a number. It's so there's a number being stored, but the thing that I'm pointing to it, to be able to point to it, I need the address of it, which is a number. It's a number, it's the location in space. So I can get a pointer to a pointer. I can just put another ampersand in front of that. So that got to be stored somewhere. The pointer is storing the location, the address. I can find the location where that address is being stored as well. So I have a pointer to a pointer. This is why you get this weird kind of thing for people like me, maybe not many other people you see nowadays, but it used to be a big thing. You know, if you want to say it's a pointer to a pointer, I would have put a P in front of it. If it's an array of pointers, it's an AP. If it's a pointer to an array, it's a PA, right? Just some kind of reasoning and convention for other people look at this and go like, oh, it's a pointer to a pointer. Because here's the other little gotcha in there. That's a pointer too. It's pointing to a chunk of memory, but I don't know it. There is no difference between enums here and ptest here. They're just pointers to a number. I don't know there's other numbers in there. So when I make an array, any array, I'm just pointing to the location of the start of it. And since I don't know if it's an array or just a pointer, by naming conventions, I use A's and P's just to say, hey, by the way, it's an array. If I don't know what's an array, just assume you got to assume it's a pointer, because either you need to be told how big this thing is and explicitly know this, or I just got to be like, I don't know, I guess it's a pointer. Okay, so let's actually drop a breakpoint on this thing and see what happens. Hopefully I don't get any syntax errors in here. All right, so move that over. I don't think it's going to make a difference. Okay, so I'm going to walk down my thing here. Test the value 4. Great. But the location of where test is at 00C9FA74. Why? It could be anywhere. It'll change every time I run my program. That location will change. You can never assume that that location is static or stable. It moves because it's just it's asking, the computer's asking for, you're asking for memory from the computer. It gives you some memory. It makes no guarantees where the hell that memory is located. Your pointers are never consistent. So they're not normally that useful beyond the one time I'm running this. But here is ptest, set the location. Ptest will store the location of the location. It is at C9FA68, which inside of that location has 00C9FA74, which is the pointer from before. A pointer to a pointer. It's the location of the location. It's like a scavenger hunt if you want. So I have a pointer to a pointer to a variable. The weird thing about this, and I didn't do what I was going to change the value here. I'm going to change this in a second. I can now output what is at this location to dereference. So I get a reference with an ampersand. I dereference or go to where the pointer is located by using the star in front of it, which I find really weird because this says it's a pointer, but if I put a star, an asterisk in front of a pointer, it makes it no longer a pointer. What? It dereferences it. So this is go to this location. What's the value in there? Okay, go to that location. What's the value there? Okay, go to that location. What's the value in there? This will be should be the value for. It is remove. Imagine if you put parentheses around this. I have the number 4, put parentheses around it, like a pointer, right? And I'm referencing it. And then I put another parentheses around it. This one rips off the first parentheses, rips off the second parentheses, and gets me where I'm looking. That's what these stars are doing. Essentially, they're walking steps in. I go from PP to P. So I go from PP test, put the star in front of it, I get to P test. From P test, I put a star in front of that, I get to test, and that's the value for. That's what I'm hoping for, at least. So let's see, one more step here. The value of this thing is 4. Hey, great. Because of the weirdness of all of this, it means I can bounce around. It means I can change a variable without directly changing the variable. It means I can pass a pointer into a function and modify some variable somewhere else versus just getting a copy of the variable. So when I pass in a pointer to something, it allows me, but it allows me to modify somebody else's variables. You've given me the I give you my home address. I can expect, you to TP my house if the exam is bad, right? I gave you my address. You can do whatever the hell you want to my house now. That's the kind of thing we're dealing with. That's what pointers are powerful for, but they're also really kind of dangerous for that. That's why I don't give you my address. Right? No one throws candy at my house. And no one's TP'd my house either, but that's because you don't know where I live. Okay, so that is the basics of a pointer. It's just the address where this thing is. I put an ampersand in front of it, it gives me the address. But because I have the address, I can then go to that location and change the data. On array, it works the exact same way. So I'm going to go one step down. This will get me a location in space. It just happens to have this value inside, which is just garbage value inside. Because when I call new, nothing gets set to safe values. It just gets garbage, whatever was there before. So this is going to be a very not nice way of writing this thing out, but I will get this. Notice it doesn't know that there's a whole bunch of other parameters in there. It just thinks there's one number. When I call new, I happen to know there's 3 variables in there, but the array doesn't. So what I want to do, let's see if I can do it manually. Okay. This is the exact same thing as walking one space over and looking in the bucket, which is exactly the same as +1, and then I'm going to do it. They are exactly the same thing. I'm pointing to the location, I move one space over, whatever, if I have it's an array of integers, I'm moving one integer pointer over what's in the bucket there. This just happens to be this square parentheses, what we've been doing the entire time since 1400. Those square parentheses, they're just a shortcut. They are take this many steps over, dereference. Okay. So what am I doing here? Let's do a couple of these around. Let's see what I get. So this is going to be some address. It's going to be a bunch of gobbledygook in here because I'm pretty sure this is gobbledygook, gobbledygook, gobbledygook. Okay, and then stop. Let's have a look at what this thing says. Here's the gobbledygook, but this was element 0, element 1, element 2. Notice what my address is. D8, DC, C, 8, 9, A, B, C. Wait, that's 4 bytes between this. And this should be 4 bytes between this and this. That's the size of a pointer. That's how big an integer pointer is. It moves 4 bytes each and every time. That is what's being stored there, but it normally doesn't make a difference. No, it's a size of an integer. Pointer is actually an array of integer pointers will actually be 64 bits or 8 bytes. No, look into that. Let's find out. I can do that, by the way. I can make a pointer to pointers, an array of integer pointers as well. That's fine. It gets really convoluted, and a lot of this is you either have to make it your own or just break it down to simple steps, trying to help yourself out. So, but this is exactly 4 bytes in between each, which is the size of an integer, what I'm storing in my array. So I can go into there, stuff an integer in that location. Go to the next one, stuff an integer in that location. The array itself is just pointing to the front of this 3 bucket chunk of memory that can store 3 integers in it. I'm just pointing to the front of this array. So I'm wondering, I want to make sure that because I think I'm walking all over the place here. Let's also delete this afterwards. Delete is how I delete an array, by the way. Not delete, but delete with the square parentheses. And I always like setting it to no afterwards. Okay. I want to see if there, I'm not sure if I hit the nail on the head, Kevin, so please correct me or where you're getting fuzzy with this. It's knowing how to go to a location or come back or find out what's at the location is the it's sort of the art form here. But oh, I want to do a couple things here. So first, P test blocking. Okay, P test. I'm going to go to where P test is pointing. That's what this thing says. And I set it to 3. What happens? I walk to the location, so I have the address. I go to the location, I change the value, and test will no longer be 4. It's now going to be 3. I went to the location, went into the bucket itself, and set the value to 3. That's what that thing is doing. I go to the location of this, I go inside of what's inside that location, and then I go inside of the location of that location, and that gets me the value. Okay, let's do nums at position 0. Let's put some values in here. 17 and nums plus 1. And let's do this one. A nums plus 2. What the heck? So what's that going to do? So I'll let you think about it for a second and we'll get to it. Okay. This says go to the location. I'm pointing, this thing is a pointer to a chunk of memory. Go to that where I'm pointing, go into position 0 in that thing, get me the value. Or modify that value. This says, here's my pointer, move 1 space over, so I'm pointing to the next thing in the array. I'm pointing to the next thing in the array. Now dereference it, go into the bucket, see what's inside. So rather than just pointing to where the bucket is, or the box of different data is, I want to look inside that. So I like to think of it as a series of boxes, right? You're pointing to a box, and then when you say that one, okay, then open it up and look inside. This next one is move 2 steps over, and then go to position 0 positions away from me and look inside the bucket, which is the same as +2, and then you're referencing it. They're one and the same. So this should be, my new array should be 17, 3, 9. And 3 chunks of 3 points in memory, one after the other, 4 bytes apart. And let's see what the heck this thing does. We don't know I should be fine. It doesn't know that I initialized everything, but let's find out. All right, okay, so test is equal to 4. I'm pointing to, it's a pointer to the 4. I'm pointing to the pointer that points to 4. I'm going to take the pointer that's pointing to 4, dereference it, so go into open the box, set the value to 3. Value for 4, or for test, is now 3. Because I went sort of the back door. There's a secret entrance into this thing, right? There's a secret way to change this value here by passing the pointer, and now I can modify somebody else's data. Okay, and then I can do my printf statement, my output, right? What can output say? The test number is 3. Okay, next up, I'm making a big old array. It has, well, it has a 17 at first, then it has a 3, and then it has a 9. All right. Notice this hasn't been initialized yet. We're about to initialize it right now. It's going to be, this is going to change to a 3. So actually, they're both the same thing, so they both change to 3. The one after that is 2, that is index number 2. And so if I output this, what I should get is 17, 3, and 9 for the values, and 3 for the numbers. Let's have a look. 17, 3, 9. The address, different address this time, wasn't the same as this last time, 30 to 34, 38. 4 bytes difference, each and every one. The size of an integer, the thing that I'm storing in my array. There is no difference between a pointer and an array. It's just a location in memory. The array is a whole bunch of locations one after the other. That's the only difference. So why do we need that for, let's say, a linked list? Because I need to know where the other data structure is. So that actually is going to be directly related to what we're doing here in the assignments and the like. So do I have oh, I do have one right here. Here we go. I made a 3D point yesterday. So I have all these new points, right? I make a data structure. It has member variables, it has functions. They're wrapped together into one unit so that the data knows how to deal with itself, essentially. It's not autonomous really, but if I tell the point, hey, point, are you in this circle? It can say, yep, I am. Just tell me what the circle is, and I'll tell you if I'm in it. I want functions that can sort of, I don't have to pass data around everywhere. I want the function to sort of know about itself. So here's me making the point. If you pass in anything other than, if you pass anything less than 0, let's say, I'm going to change the value and just set to 0. So if it's -17 and -3, it'll be 0 and 0. It just minimizes down to 0. 0, 0 is a minimum point value. Here's me making, and I'll do I want this one. Let's do that. Oh, there we go. This thing's going to make another data structure. This makes data. It has to be stored somewhere. This makes the data, it makes an object. So this makes an object. It's stored here in main, and then it gets destroyed when I leave main. This makes an object. lives and dies within main. This makes an object and doesn't get given back to the system until you close your program, which means it's my responsibility to give it back. If I call new, it's mine. I get a pointer to something, and that pointer is permanently mine until I give it back. Whatever memory I store, it's mine until I give it back. Which is weird and dangerous and all sorts of things. So that's essentially the plan here, is this thing will make temporary variables, give them back. This thing will make a permanent variable and keep it. So let's do static test. Can I call it that? I don't know if I'm allowed to call a function static test. Okay, I'll make it as I'm going to pass back in a new point. All right, so we're going to do this. That's going to be a new function that I'm going to test out. It's going to make a new point. And it's going to return this. Okay, and let's make it something. Dynamic array. You will see this a lot in assignment A5B. We have arrays of shapes that we're going to be making pointers to shapes, arrays of pointers to shapes, because I cannot make an array of shapes. It will automatically make that array and fill it in without me doing anything about it. So I need to make arrays of pointers to shapes, otherwise they get created automatically. We can do that one next, actually. And then I can just return the key. Great. Here's what I want to do with this whole thing. The reason why I wanted that. Okay. I want something like this. I just want somebody, I really want to have. Oh, let's put that into new point. Bear with me for a second. New point. Do I have something to print it off? No. Sorry. Yeah. All right. I'm going to be using standard namespace. No. Standard error. Okay. I have my current X, my current Y, and I'm just going to output something. The reason I want this is I just want to be lazy. Let's see if it's going to work for us. All right. Next up. I'm going to make a new point, and I return the pointer. I'm going to make a new point dynamically. Then I'm going to call p static print data to print out the information. P static, p dynamic print data. So I'm going to make two different kinds of this class that I have, new point with a class. It's a point. It has X and Y and a bunch of functions. I have two different functions here. One that's making a variable without calling new and returning a pointer to it. The other one where I'm calling new, which gives me a pointer, and I return it. Now let's see what happens when I run this. So let's compile it. It's not going to end well. It's going to end really badly. I need to get out of this. And boom. I knew this was going to happen. Why did it happen though? Exception thrown. I got a bunch of weird crap going on. What's going on? Let's see my call stack. That's what this thing is, right? So what function calls print data? It's over here. Let's have a look at where I am. And it seems like it's coming from there. It's actually, I know it's coming from right here though. The reason I know this is I know what the problem is. What is p static? It's this address. Do I have that address anymore? No, I do not. That's the problem with static variables. That's the problem with static arrays. It's the problem with static anything. When I make something that's static, let's say like right here, I'm making a brand new object right here, and then I give the object back right here at that curly brace. I send the value back, that's fine. I'm just sending the address where this thing was. But then I gave my memory back to the system. And this is what bites people on the backside all the time. So I've given this memory back to the system. I still passed back where it was located. So there was something there. It got given back. So I rent, I'm not even renting a house. There's all sorts of metaphors for this, right? I temporarily get something. I give it back. I say where it is, and then I give it back to the system. Now, so I say I'm going to have a party. I tell you my address, and then I move. You show up to somebody else's house and have a party in their house. That's not cool, right? That's the kind of thing we're doing here. Unless you know it's yours. Like if I'm done here, as soon as I'm done with this function, this gets given back to the system. Oh, sorry, I clicked the wrong thing. So I need to stop this for a second because I need to show you, I need to turn that off just to prove to you that this is actually what's going to happen. It's giving you an address to this new point, but the new point is given back to the system, just like all our integers were given back to the system. I automatically will delete this thing as soon as I get to the end of that function. I will actually call the destructor on that object as soon as I get to the end of that function. If you don't believe me, we can also do that. Okay. So I made an object, I pass back the pointer, then it gets destroyed. And so this is pointed to garbage. It's pointed to whatever the heck was there. You know, the location where it was, but that doesn't mean there's anything available. This does, that works just fine. I still have access to that. In fact, in order to be done with it, I need to delete it. I need to go delete p dynamic in order to give back that, to get that object back. So let's try one more time. Turn off the static version of print data. The other one should work just fine. Boom. Just fine. No harm, no foul. That's the reason I need dynamic memory. That's why I need to call new sometimes, because I don't know what's going to happen. And afterwards, I almost didn't do it, but I should always do it. Make sure you don't accidentally use it. I'd rather have a null pointer exception, which is guaranteed to blow up, than, you know, I gave back the memory. The system doesn't know I gave back the memory. It starts stomping on other people's data. If I set it to null, I guarantee it's going to stop right there when you're trying to use it. Not accidentally it starts using other people's data, which can actually happen. So I always set it to null again. That's not just me. Everyone, most people do that. Okay. So this is why we need dynamic memory. Up here, I did dynamic memory as well. Let me think of a good example here. This may not even work actually. I'll show you why it may not work. Okay, so I'm going to I'm going to have an array of new points. So it's an array of new points. I'll have actually an array of, which one should I do? What I'm trying to do is have an array of, well, let me do it a different way. And let me do one other thing first. New point, H. I'm going to make a destructor as well. Destructor, meaning every time I delete something, this thing is going to be called. When this finally gets given back to the system, this gets called. All right, what do I want to do? I just want to say something like this. See out. Something like that. Something silly. That's all I'm doing. I just want to know when I hit this thing. Okay. So what I want, that's for breakpoint in this thing. I'm going to hit my breakpoint every time I delete something. We're going to see when this thing gets called, when the first time this thing gets, one of these new points gets deleted. It might hopefully be a little revealing. Breakpoint, where am I? There we go, static test. This point was created. I am now deleting it as soon as I'm done with my function. Whether I choose to or not, it automatically gets deleted. It automatically gets given back. And I call my destructor automatically. If I want to call new, I get to keep that pointer around. But what you'll notice is after I call dynamic test, we're not going to see that breakpoint. That breakpoint get hit. We'll only see that breakpoint get hit when I call right wherever it is. Print data, it'll be right here. That's when it's going to be deleted. Not here, not here. It's going to be called when I explicitly call delete. Okay. Now it's getting back. Let's look where the heck this was called. Where am I? Oh, wait, I'm deleting dynamic right here. That's where it's being called. That's when the destructor is being called. I've already printed off, and if you don't believe me, here it is. P1 is 3 and 5. It should be P1 anyways. It should be point or something like that. I gotta change that. But this is I only give it back. I only call delete when I say I'm well and done with this thing. That's one of the weird things about dynamic arrays, but also dynamic arrays have the same problem. I don't give it back until you explicitly give them back. And when I make a dynamic object, when I call new, I have to call delete. And the reason we want this is if I have a bunch of shapes for my program, I want to keep those alive and well until I'm done the program at the very, very end of the program, not immediately afterwards, not soon afterwards, not when it feels like it. At the end of my program, I'll give all those shapes back. That's why we have to do it. Okay, let's see one other thing. Again, I'm rambling on about pointers right now. I'm hoping that this is useful. Stop me, ask questions if there's something you would prefer for me to go over. I'm just hitting a bunch of like greatest hits questions here. And not even maybe greatest hits. I think they're important or I think they're useful, but that doesn't necessarily mean they are. Okay, I want to do something with arrays because, okay. Let's make, I'm going to make a static array. I'm going to make a dynamic array of objects, and I'm going to make a dynamic array of pointers. 3 different arrays. Okay. Okay, so I'm going to make an array of new pointers. They're just objects. So I'm just going to make an array of these things. Once. Okay. And I'm going to make 20 of them. That's it. You're going to notice something that's going to go terribly wrong here. That's what's going terribly wrong here. So I could do, I think I can do this. Okay. I think that work? I don't think that's going to work even. I hate when I get into this situation. So if I have no default constructor and I make an array of things, I think there's a way to do a certain default constructor that all of them have the exact same value. But it doesn't always work. Okay, let's do another one of these things. Another constructor. This, by the way, is overloaded. It's a type of polymorphism. I have 2 constructors that take 2 different inputs. They both make an object, but you have 2 different inputs, and therefore you have different behavior. It's really useful when I want to make sure that this thing works as I expect. Okay. Point, that. X is equal to 0, Y is equal to 0. My default constructor. It's a blank constructor. It does nothing other than if I want to make a point and I don't want to put anything in it, it'll be 0, 0. That's by default. That's all I want to do with this. So I can make a point with nothing in it, so it automatically goes 0, 0. Or if I want to put in a starting value, I can do that. Which one do I call? Which constructor do I call? Depends on what my parameters are. Overloaded. I have 2 of the same, essentially my constructor acts like a constructor, but does something slightly different depending on the input. Which one do I call? If I pass no parameters, I get this one. If I pass 2 parameters, I get this one. If I pass 1 parameter, I get an error. It has to exactly match. Okay, now let's look at my source here. Okay, now I can do that. So here's my array. They're all going to be 0, 0 everywhere along the way. Okay. New point. Okay. Let's make that size 20. What's going to happen there? I'm going to make an array of pointers. They're all going to be 0, 0 as well. But I have to make sure I call delete at the end. Points 2. 2 different things. Because if I don't do that, it won't get given back. That's my pointer from now on. If I do not call this delete, what happens? It's mine. I made an array of 20 different objects. If I call this 1,000 times, I make 1,000 times 20 of that object. It's going to get big. And then I would immediately throw away the pointer because this pointer just goes away. I don't get to keep it. I didn't keep it anywhere. I didn't store it somewhere. If I don't store this pointer somewhere, I say, I'm claiming this thing over here, and then I don't go back. You go on the top of Everest, you plant a flag down, or you go to the moon, you plant a flag down, it's mine, and then you go back home. You're wasting, right? The US plants a flag on the moon, the moon's theirs now, right? Now no one can use it, they're not using it, it's just there. You've wasted a moon. Right? It's that sort of thing. I'm claiming it, I didn't give it back. I've lost track of it now. I'm host. Okay. So this is not going to be given back until at the end, which is kind of weird. Okay. Technically, because I have this delete here, this will be the P2 will be deleted before this one up here. This will be deleted automatically as soon as I get to that curly brace at the end. Okay, we need one more thing in here. And I'll do a for loop with it. Just then, thank you, plus. And I will also do a cout statement. How do I want to do this? Index. Let's do that. So I'm going to have a PTS at index I. That's going to be a point, right? So I can call the data a PTS2 position I. And again, I can call print data. Well, going to be 0 zeros again. And prints at the end. And then I'm going to have one more array in here that I'm going to be dealing with. And I'm not sure if I'm going to be calling print data on this thing. So let's have a look at what I'm going to be doing here. This is a pointer to pointers, or a pointer, an array of pointers. That's actually what I want. It's an array of pointers, 2 points, this repeats 3. New. It's an array of pointers there. The reason I might want this is I'm going to automatically make 20 new points. Whether they're supposed to be new point 3Ds or something else, and making 20 new points blindly. Right, I call new on the array. I will make everything. I make all of those of that data. I set everything up. I cannot make a child class in there. There are no children allowed in this thing. They're all just new points. With an array of pointers, if I have a child class, I just happen to have a child class. I can initialize these things when I need them. When I make a new object, I can put it in there when I want it to. I don't automatically make one. And I can make a whole bunch of different kinds of, I can have a 0.3D, and I can have this other child class, that child class. The media library we had media, pointers to media objects, but they could also be book media, they could be library media, they could be all sorts of different things. Because until I actually call new and put that pointer in this array, I'm not making the object. I'm making it when I need it. That's the reason why we end up having to go with this sort of archaic system of having an array of pointers to things. So this is an array of pointers to new point objects. And what I'm going to do is if I is divisible by 2, then I'm going to make it A, B, PTS 3 is equal to new. We're going to make it equal to 3D, and it's going to be values 3, 4, 5. And the other one else lazy. Otherwise, we're going to have one of these. So half of them are going to be new point 3Ds, half of them are going to be new points. And then for each of these cases, I'm going to also, let's see what's wrong with this here. That's what I did wrong here. Oh, I can't just call that. All right. There we go. Remember that these each call cout, so I can't put it in a cout statement. If it returned a string, it would be different. A PTS3, it's a PTS3. An array of pointers to PTS3. All right. Position I dot the data. Now it's an arrow because it's a pointer. And there. All right. So what is this doing? Actually, I may have to go soon. Okay, so what is this doing? I am making three different arrays. An array, automatic static array, a dynamic array, two different objects. But I automatically make those, as soon as I make this array, I'm making all those objects. And this third option is I'm making an array of pointers, and when I need the object, I make the object and put it in the array. This will give me an array with 20 different points. This could be an array with only 3 points inside of it. I just need to keep track of how many I've made so far and keep that number around. I won't make any more objects than I absolutely need to. That's the point. Okay, so this thing, then after that, I'm going to, for those 20 times around through the loop, I'm going to make a new pointer, a new point, either a 3D one or a 2D one, put it in my array. And here, okay. I have a couple more things that I need to do. I'm hoping you're going to realize what horrible about what I just did there. It's an array of pointers. I didn't free up the actual objects yet. I need to, that's one other thing I'm going to actually have to do. So I need yet another for loop in I guess less than 20. I'm going to need to go to each one of these things right here, because I called new, delete each and every one of those things separately. So that is a pointer to one of these. It's a pointer to a new point. I delete each one of those separately. Let's make sure I do it right. So because if I don't do that, what happens? I throw away all the array of pointers, but I did not get back the memory. I just throw away the address. I have a piece of paper saying where the address is, or where the house is. I throw away the piece of paper. The house is still there. I just throw away the piece of paper. So this is me making, this is me deleting an array. This is me deleting an array. But if I have an array of these dynamic objects, if I have an array of pointers, essentially, I need to delete each of the objects, then delete the array. Otherwise, I still hold access to all of those objects. Nobody can say boo about it. It's mine, I claim them, they're mine, I'm holding onto them, and I've lost all access to them. It's, buried treasure and then losing the treasure. It's there in the ground, you don't have access to it anymore. So let's roll this beautiful piece of footage. If you know that really, really old commercial. You shouldn't know that really, really old commercial. Still. Okay. This thing here, I would need to run test arrays. All right. Let's not run test arrays. All right. Otherwise, I wouldn't do this at all. Okay. Let's see what I got. All right. That's my destructor. I'm going to turn that off and just continue. Let's see what I got. Let's go back. Oh, that's a lot of stuff. Every time I call the destructor, I call new point was given back. That's called 60 times, right? That's 60 different calls to that destructor, more than that actually. But that array of 20 elements, called 20 times. The array of dynamic array of 20 elements, called 20 times. And that array of pointers to dynamic objects, called 20 times. All of those are here. But here's the actual what we were doing before. So here are the points I had before. The very first one is 0 and 0, 0, 0, 1 and 2, 0, 0, 0, 0, 0 and 4, I changed something with my 3D array. I forgot to change back a little while ago. Okay. I changed my get X value, which I didn't need to at all. I was showing, it was a demonstration yesterday. I changed back. Literally, me being stupid. I was showing how inheritance was working. What I should get is every second one, it would be 3, 4. And the other ones are 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. Because I'm making a 3D point, a 2D point, 3D point, 2D point. Notice that my 3D point doesn't have a special print method. So I'm just using the parents version, which means it doesn't even know there's a third point. It's just printing out the X and Y value. Boom. All right. So I'll give it back. All right. 0, 0, 1, 2, 0, 0, 1, 2, 3, 4, 0, 0, 1, 2, 0, 0, 3, 4. Back and forth, back and forth. And at the end, when I'm done with this, I go through my, let me do my array test here. When I'm finally done with this, I get back all of the dynamic objects I made, every one of them, set them in null, and then I delete that array that holds all the pointers. If I only did 20 of these things though, if I only called new 20 times, so let's say 10 times, I don't get 10 objects. That's sort of the point of it. And pointers and all this kind of stuff is really wonky. But the reason you need to pass a pointer is that's my memory and it's never going back to the system. I'm making it somewhere else. I'm passing you where it's located. I'm passing you the location where the secret super object I've made for you, just for you, is located. And that's why you get an object, or why you get a pointer to an object back when you call new. Because it's yours to deal with. It's not part of that function. It doesn't get given back automatically when you're done with the function. It gets given back when you're well and ready to give it back. That's why we have it and why it looks so weird. That's why we have it being done this way. It's a very C++ specific thing, and it's a pain. I fully admit it's a pain, but that's why it looks, all of these things look like this, because you need to know where things are located and whether you can get them back. And this hopefully shows all those things. Okay, I rambled on without anyone stopping me. Last sometimes anyone wrote anything was at 4:14, and I've been talking since then. Yeah. I have to go because I have to actually make supper for everyone. It's already made, I hope. But let me know if how things are going. What I was hoping to do, they're in my 1400 class, and I did a survey for you guys. I asked, do you guys want something that is ridiculously, simplified? Not this, because that's not necessarily that simplified, but do you guys want to go back to basics on some certain topics, or do you want to have slower pace on certain things? Or do you just want yet another review before the exam? The exam is next week on Wednesday at this time, essentially at 4 o'clock, 4:05. It goes up to, but not including the NFC. I'm more than happy to try and squeeze in some kind of review session if you want. I need to know, so I need to sort of circle back and see how you guys are doing. The key is a lot of this just requires practice. So if you haven't made a lot of objects and you sort of had trouble with A3 or had trouble with A4, just make sure you get some practice before the exam. Okay. Anyways, I'm going to take my leave of you guys, and hopefully this was useful. I hope pointers make a bit more sense. A lot of this takes just staring at it until it finally comes into focus. I wish I had a better answer than that. It is knowing how it all sort of fits together, and that just requires having that light bulb come on. That's at your own pace, unfortunately. Okay, with that, I'm going to stop everything. Thank you very much for listening, and I will talk to you guys later. Thanks.